Okay, so this is a tweet by our friend Greg Egan. So, sorry, this one I started with the one where he fixed a glitch, but I better explain what the first one was. What's going on here? Okay, so here's what's going on. So why don't you say what he's trying to model here?
See, a satellite has the least kinetic energy when farthest from the central mass. If it releases mini satellites moving tangentially to its orbit, but whose kinetic energy per kilogram is less than its own, by that minimum, they will all pass through the second focus of its orbit all at the same speed.
Alright. So, like, all the colored dots are the kind of the tangent lines that go off at preset intervals. I guess this is the first focus of its orbit, the central mass, and that's our satellite. And it looks like the balls are all passing through this point, which is the second focus.
So they all have their own sort of orbits.
All right, so now let's go down to the one where there was a glitch that got fixed. So he's got a satellite going around a central mass.
Mm-hmm. Yep.
And it releases, so he says it has the smallest kinetic energy up here. So do you know what that means, kinetic energy?
It's kind of the speed.
It's related to the speed.
How fast it's moving.
Yeah.
So it's moving the slowest there, and I guess it just kind of drops the satellites.
It drops them along the path of its orbit.
At consistent intervals, or at consistent times.
But the satellite has an energy equal to, you subtract away that lowest amount of energy. Mm-hmm. So you can see at the top here, the satellite just falls straight down, even though it's released along the tangent line. So why do you think it falls straight down?
So that's why it's moving the slowest.
So it's moving the slowest there, and it's subtracting away that energy. So even though it's supposed to be released along this way, it's released along that way. You could think about it with no speed. So what do you see from these satellite paths in this amazing animation?
Well, it's symmetrical again. I guess the ones kind of down here, so I can see it. Yeah, these kind of blue ones are the ones that are moving the fastest. Kind of the green and the blue. But they have, I guess it's also they have a symmetrical orbit, but sometimes like in here it's hard to tell because some of them do go all the way around, while some of them just kind of bounce back and forth. Like this one only has this little bit.
I think all of the mini satellites that have been released, they all fall into their own orbits, and they stick to those orbits, because otherwise after it comes back around and then stops making new paths, they didn't stick to their orbits, we would see new paths being created.
That's both a great observation and also kind of a lucky observation. That's the thing we're going to look at next. Do you notice anything about the individual orbits? So just focus on a single satellite that gets dropped and look at that satellite's orbit. Do you notice anything about that orbit?
Well, it looks like they have to go around twice before the orbit sort of stabilizes, I guess except for the one that's a straight line. And then when they go around twice, it's sort of a rotated version of the first version. Like if you look, there's like the curves down here and the curves up here that kind of correspond with the blue and the green ones.
What do you mean they have to go around twice?
Like they have to orbit this central thing. Like if we watch one of these, it goes around and then around again, and then it's a stable orbit. So like the orbit is two rotations around this thing. That's why there's the second line that goes around, I guess.
Yeah, I don't know what you mean by the second line. Why don't you follow a single one? Just pick one.
Like this line, it goes around, and then I don't know. It's hard to see, but I think there is second lines like.
What? I don't see any lines.
Like
what do you mean by lines?
These orbits.
Okay.
That I just think these dots go around twice. like around twice. I can't really follow them because there's too many lines of the same color. But I think because it looks like when they go around the first time, they're in a different spot, and then they go around the second time. That's what creates all these crosses, and then the orbit's stable, and they loop in that pattern.
What do you see?
Just looking at the second one here, I didn't see a second orbit.
Yeah.
I just saw it just follows the first path that it makes. Well, maybe when it resets, just following this one here. Goes around again, goes down, bounces back up, and then immediately links up again.
Mm-hmm.
And then doesn't change.
I guess
from
these
that
ones
orbit.
down here are just wider, so it looks like. I don't know. It looks like they're going around a second time, but I guess they're not, and I guess it's just because they're crossing over each other.
Okay. Do you notice anything about the shapes?
I mean, this kind of loop of all of them, because they're connected. I mean, that's kind of an interesting shape. It's like, well, the loop. I'm not sure what the loop is doing, like why it's opening and like it's like not connected there. But it's still a pretty interesting shape.
Okay. Well, let's move on to the next one.